Hello friends, in today's class we'll be talking about the method of joints, and I wanted to find the load in the each member of this truss. So I'm going to start with drawing these reaction loads. So these are the reaction loads RAX, RAY, because this is a pin joint and this is a roller joint, so only one perpendicular direction load will be shown here. And let's write the equation. So sigma f of x equal to 0, and then other equation is sigma f of y equal to 0. So what are the forces in horizontal direction? Horizontal direction forces RAX plus RFY, both acting in the forward direction, so I'll consider both as positive, equal to 0. Is there any other force acting in the forward direction? No. Now in f of y equal to 0, so vertical forces I'll consider. So there are, so RAY acting in the downward direction, then there is 2 kips here acting -2, then there is this 2 kips -2, then there is this 2 kips -2, equal to 0. So RAY equal to negative RAY equal to 8. RAY comes out to be -8 kips. That's what we figured out, RAY value, which comes out to be -8 kips. Now if I wanted to find the other forces, let's say I wanted to find RAX. So to find RAX, I'll take the moment about this point F. So taking moment about F. So if I take the moment about F, what I'm gonna do is I'm gonna say 2 times this, 2 times this is 8 plus 8 plus 8, 24. This will be clockwise, this is trying to rotate in clockwise, so this is negative, minus 2 times 8 plus 8 is 16, and then minus 2 times 8. And is there any other force? RAY will be in the line of action from point F is the same, so there is no perpendicular distance for RAY from this point, so I won't consider that force, but RAX I will consider. Then RAX is also in the clockwise direction, negative RAX times this distance. I wanted to find this distance given to me is 6, so this is 6, which is equal to 0. So 24 times 2 is 48, negative 48, negative 32, negative 16, negative 6 RAX equal to 0. So I'm gonna say 48 plus 32 plus 16, because all of them are negative, that's why I'm adding them. 6 RAX equal to 96, and RAX comes out to be 96 divided by 6 is 16, negative 16 RAX value comes out to be. So I figured out these two values. Now you can also check these values. Is there anything we are missing? No, doesn't seems like. Now what I will try and do, I'll write these values at a side. RAY came out to be -8 kips, and RAX came out to be -16 kips. And then same way, if you want to find, you can find RFX also now. So equation which we've written in the horizontal direction, I'm going to erase this. So the horizontal direction equation was sigma f of x was equal to 0, and we wrote RAX plus RFX was equal to 0. So RAX came out to be -16, so -16 plus RFX equal to 0. So RFX came out to be +16. So I'm going to write it, RFX came out to be +16 kips. So I figured out 3 values. All the reaction loads have been figured out by me. Now I will start finding the load in the members. So first of all, I'll draw a free body diagram about point C, because load is given to me here. So let's try and draw the free body diagram at point C. You could have done this as a first step also, but usually what I like to do is I always like to find the reaction loads first. So this will be the free body diagram. Again, the forces I'll show is away from point C always. So this is B, this is C, this is D, and this is, if this is 8, this is 6, so this value will be 10. So I'm gonna say sigma f of x equal to 0. We're doing the method of joins. So sigma f of x is equal to 0, which says to me dc minus dc minus bc, this will be 8 over 10 equal to 0. So this is minus bc 0.8 equal to dc, but we can't solve it further than this because I don't know these two values. So I'm going to write the other equation, sigma f of y equal to 0. So I'm going to say sigma f of y is equal to 0 bc, which I'll multiply it with 6 over 10, then minus this is positive because it's acting in the upward direction, minus this 2 keeps, it is acting in the downward direction, so 0 equal to 0. So this is bc times 0.6 equal to 2. So bc comes out to be 2 divided by 0.6, which comes out to be 3.3 positive. This is positive, so this is a tensile force. I'm going to call it tensile. I'm going to write bc equal to 3.3 tensile, and then I will try and find the dc value. So dc value, because I know the value of bc, so I'm going to plug it in here, negative 3.3 times 0.8, which is dc, times 0.8, which will be 2.66 equal to dc value. So this is what we figured out, and now I'm going to draw the free body diagram at point B. So if I will first of all write down this value also. This is negative, so dc comes out to be negative 2.66. Now I'm going to draw the free body diagram about point B. So from point B, it acts in the downward direction, and then this is acting in this direction, BC, and then this is D, and then there is something in the opposite direction, A. So I can write down the equation sigma f of y first of all equal to 0. So BD minus BC times, this is, again, this is 6 and this is 8, so this value will be 6 over 10 because this is 10 equal to 0. So I've written down the equation. Do I know the value of BC? Yeah, BC value is known to me, which is 3.3 minus BD, and I can find equal to BC times 0.6 equal to 3.3 times 0.6 equal to negative BD, which comes out, BD comes out to be negative of 3.3 times 0.6, which is equal to 1.98, negative 1.98. So I can say BD equal to negative 1.98 or 1.98 compressive. Whatever way you want to write it, you can write it. So I'm going to erase this again and we'll try to find the other forces. So let's look into the rest of the ocean. So now let's look into the value of, let's try and find the value of which one? AB. So if I wanted to find the value of AB, I'm going to call it as negative AB positive 8 over 10 BC, and then is there anything else? No, which is equal to 0. So negative AB equal to negative 0.8 BC. So 0.8 BC value is BC, again 3.3. So this is negative and negative cancels out. So AB value comes out to be 3.3 times 0.8, which comes out to be 2.64. AB value is 2.64. Again, this is a tensile force, so I'm going to keep it as positive. Means if it is positive, so it is a tensile force. So rest of this question I'll do it in part B of this video. So hopefully you were able to understand up to this point. for if you wanted to see what are the value for AD, AE, and EF and AF. So you can join me in the next video. Thank you. Bye now.